Hi, I'm Elijah, and this is my project on how I found the approximation of pi. I started with a polygon inscribed in a circle, and I used a pentagon. I divided the pentagon into 5 triangles as that green triangle, because there's 5 sides in a pentagon. So then I divided 360 degrees by 5 to get the number of degrees for that inner angle in the pentagon, and that got me 72. This triangle is hard to use though, so I tried to make a right triangle by drawing a straight line down and creating this new blue triangle. This is half the size of the green triangle, so this angle up here is 36 degrees, because that's half of 72. Now, the way I get the area of this, to eventually get the area of the pentagon, is by finding the base and the height. The way I got the base was I needed to find the sine of this. So, because I already had the hypotenuse, which is 1, because that's the radius of the circle, I did the sine of 36 equals x divided by 1, because that's what sine is. And x divided by 1 is the same as x, so sine of 36 is x. I did pretty much the same thing for the height, which is y, but instead I used cosine, because cosine is adjacent over hypotenuse. So, for the height, it is cosine of 36. So, to get this triangle, the blue triangle area, is 1/2 base times height. So 1/2 sine of 36 times cosine of 36. There's 2 blue triangles in a green, and then 5 green triangles in the pentagon. So I had to times that whole answer by 10 to get me this approximation of pi, which turned out to be 2.378. As I added more sides to this polygon, this excess area would shrink, bringing this closer and closer to pi. It was rising from beneath and coming to meet pi. Circumscribed was very similar, but instead of drawing it to the points, I drew it to the 5 points that connected the circle and the pentagon. Then, as in the first one, I made a right triangle, which is this blue one here. The difference is, this radius is the height, which is 1, so that makes this problem a lot easier. All I had to do was find the base z. And the way I find the base when I have the height is by tangent. So, tangent of 36 is z over 1. So z is tangent 36. So then, for the area of this blue triangle is 1/2 height, which is 1, times the base, tangent of 36. And then that whole thing times 10 to get the 10 pieces of the pentagon, which is 3.633. This number is above pi because this pentagon is bigger than the circle. And as with the first one, when I add more sides, this excess will shrink, bringing this closer to pi, but coming from above rather than below. I found the parent function by noticing that this number 10 is twice the number of sides as the pentagon. And so that's 2n. And when you multiply that by 1/2, it simplifies down to n. Now, I had some trouble getting the numbers for sine and cosine here, but eventually I noticed that 36 is 360 degrees, which is how many there are in a circle, divided by 2n, or twice the number of sides. So, 360 over 2n simplifies to 180 over n, and that's the same for both of them. So my parent function for inscribed is n times sine of 180 over n times cosine of 180 over n. It was the same with my circumscribed. This simplified down to n, the 1 went away, and then the tangent simplified out to 180 over n. That was my parent function for some circumscribed. Thank you so much.